Alright, first thing, whenever we want to use square root method, there's basically two situations, is when there is no bx term, you will use it. So you see on numbers 1 and 2, there's not a bx term present on either of those. The other situation is when there is a perfect square on one side. Sometimes we'll have to make that, and we'll see that more in the next lesson. So when there's a perfect square trinomial, actually. So there will be a bx term, but something that you can make where you can use square root method. Alright, other than that, you'll still want to use factoring and graphing. So on the first problem there, all you got to do to solve it is just plus or minus the square root on both sides, and yes, you must use the negative square root as well, because not just 3 can be squared to give you 9, but negative 3 could be squared as well. So there are two answers. The way we would have written this previously in the factoring, when we did it by factoring, is x equals negative 3 or x equals 3. But really what I have written right here is the same thing. Plus or minus 3 is your answer. Alright, so something else happens here on number 2 that you need to be aware of. So when you're solving by square root method, you'll go and do your inverse operations. We'll subtract 9 from both sides to begin. So I'm going to have x squared is equal to negative 9. Then I'll plus or minus the square root again. So x will equal plus or minus the square root of negative 9. Now this creates a different situation. One of the rules in math is for real numbers you cannot square root negative values. That is because if you square a positive value or a negative value, you'll always get a positive answer. So how do we get around this? We can create a new number. It's called the imaginary unit, and it is I, which represents the square root of negative 1. And again, that's referred to as the imaginary unit. Moving right along, how it applies here is x would then equal the positive or negative I times the square root of 9. So that got the negative out. And I can square root 9, which is 3, so 3i. Plus or minus 3i, I should say. That's only going to be done if the square root has a negative inside it. Looking at number 3, this can also be done with square root method because there's no bx term. So first thing I'm going to do is add the 160 to both sides. And I'll have 5x squared is equal to 160. Then I will divide by 5. And so x squared would equal 32. Then I will square root plus or minus square root of 32. Now something we learned earlier in this chapter is that you actually need to simplify that square root. This square root could be divided by the perfect square 16. 16 goes into 32 twice, and the square root of 16 is 4. So x equals positive or negative 4 times the square root of 2. And there it is. Alright, on number 4, there is a bx term, but it's actually already been written as a perfect square. So it's being squared. I'll plus or minus the square root on my first step, so x plus 7 would equal the plus or minus square root of negative 75. Now I'm going to simplify that plus or minus square root of negative 75 really quick. First of all, since it's the square root of a negative, you'll have I. That way it's square root of positive 75 now, since I've represented the square root of negative 1 with the imaginary unit. Now I'll simplify the square root of 75. 75 can be divided by the perfect square 25. 25 goes into it 3 times after all. And now I can square root the 25, which is 5. So x plus 7 equals positive or negative 5i root 3. That radicand of 3 will just stay right there, but I was able to square root the 25. Picking this up on the top right, since I ran out of room, I will subtract the 7 from both sides, so x will equal negative 7 plus or minus 5i root 3. And that's your final answer. That's as far as you can simplify it. You usually want to put this rational value first and then follow that with the imaginary or irrational value second. On this other example, example 5, it doesn't look like you can use square root method because of the minus 8x, but actually you can because this happens to be a perfect square trinomial. Let me show you, because if you factor it, it would factor as x minus 4 times x minus 4 on that left-hand side, which is simply x minus 4 squared. Now what we'll do is go ahead and plus or minus the square root of 12. And that's not going to be imaginary, but it's irrational. So I'm going to actually divide 4 out of 12. 4 goes into 12 3 times. Now I can square root this 4, which is 2. So x minus 4 is equal to the positive or negative 2 square root 3. I'm going to go ahead and add the 4 now. So x equals positive 4, once it adds over, plus or minus 2 times the square root of 3. And I'm done with this problem. Now, that's much more intense than what you're going to have to do on the assignment. On the assignment, you're actually going to be told to do square root method on these first 6. On the next group, you're going to determine whether you're going to factor or do it by square roots. Now, when it says factoring, you can also use graphing calculator. For example, on number 13, I'm not going to do this with square roots because there's a bx term. It's already equal to 0, so I'm either going to solve it by factoring or solve it by graphing. Your choice. But on number 15, I'll do that one with square roots since there's no bx term. Now, I am going to do an additional example of number 10 here, and I'm going to pick that up right up here on the very top. So on number 10, you're going to end up with a fraction, but it's no big deal. Go ahead and divide by 9 on both sides. So if I divide by 9, x squared would equal 25 divided by 9. And now go ahead and plus or minus the square root to solve for x. So the plus or minus square root of 25 over 9. To finish this problem, you would simplify that root, but that's actually a pretty easy root to take. So on number 10, your final answer is positive or negative 5/3. Because the square root of 25 is 5, the square root of 9 is 3, 5/3 can't reduce anymore, you know you're done. Alright, that was number 10 for you. You finished the rest. Thank you very much.